industry. So Mr. Joe Chen, he comes from a company called Dassault System. Dassault System, you may not know Dassault System. You may not heard of it. But you probably have heard of SolidWorks. It's a CAD software, especially for engineers in mechanical design or CAD design. Or maybe you have used some softwares to simulate some kind of problem. Or maybe you have seen some simulations on YouTube. So Dassault System is a huge company that has multiple kinds of softwares. SolidWorks is one of the famous ones. And so I invited Mr. Joe to give you guys an idea of what Dassault System is doing, and hopefully you can learn from him about how simulations can help in the field of engineering. Okay, so without further ado, let's have our hands to welcome our speaker.
Good afternoon, everyone.
Good afternoon.
Oh, come on, everybody's sleepy. Come on, give me some energy. Good afternoon, everybody.
Good afternoon.
Okay, nice. You guys want to see in the front? Or are you just going to hide and see in the back? And then doze off?
Yeah, just
okay? So my class today is going to adjust based on how much people fall asleep. Okay? The more you sleep, the more easier I'm going to go with it. Okay? So let's relax. It's not going to be a difficult class. Okay? And there will be a pop quiz afterwards. Okay. Right? So anybody want to move forward? There's a reason I tell you to move forward.
It's okay. Yeah. Just
Okay.
come over.
You guys are shy?
Yeah.
You don't have to take notes.
Just come over.
No notes. Okay? Or I have to go up there. Either way. Okay. Okay, anyhow. Let's start easily, okay? So who sleep, raise your hand. Who sleep before 10 last night? None? One? Okay. Who? Oh, 10. Wow. Then two less homework. Okay, what about 11? 12. Before 2 a.m. Wow, what were you guys doing? Studying hard? Nice, that's university life. Okay? The reason I'm asking this, I'm going to tell you. After you get out of school, you don't sleep at all. Okay? That's our life, and I'm going to show you my life today. Alright? So I understand why you guys, okay, let me see what is this page. Okay. I totally understand why you guys sleep so late. Okay? So I'm going to teach you the reason you sleep so late. Right? Right? But today's class is not about Netflix. It's about technology future. Okay? I'm going to let you know what I'm doing and what the world is doing right now. And hopefully answer some questions and before you guys fall asleep. Okay? Well, let's start with that. Okay? So, technology. Okay? It's the future. You guys want to make money or you want to improve the world? You have to decide. Okay? So, before we get into technology, I got to introduce my company. Okay? What kind of company we were or are. Back in 1981, okay? So we started designing, okay? It's like way before your time. Everybody was drawing, designing cars, you know, buildings on a piece of paper. It's called drafting. right? You probably never seen it, or you never done it, right? There's a big table with ruler, and afterward you have AutoCAD, okay? There's a company called Autodesk. They basically transformed the drafting into a computer-aided design called CAD. Okay, and basically it was in 2D. And then back in 1981, we turned into 3D. Okay, so in 1989, we introduced a concept called digital markup. Okay, basically it's inside the computer, you can see 3D models. And we started with an airplane. We are very famous with aerospace, okay, design. Basically, you use our tool to design airplane. And if you see discoveries, airplane is a very complex, okay, product or plane to design. And later on, each concept from aerospace on, each concept of the that was used or applied on the aerospace, we use it on cars, okay, even in city infrastructure, and or in 2020, we even use like a different kind of 3D design on your heart, and we're gonna get into that. Okay, so hopefully I haven't lost you yet. Now back to our new technology topics. Okay, does anybody have an idea how is this iPhone made from the beginning? Right? If you have no idea, well, back in university, I have no idea how things are made. Okay, I only can watch Discovery or NGOs. Okay, they show you those amazing factories. But before you can actually produce this, you have to make design, 3D designs. Okay, raise your hand. How many of people you have like use CAD tool? 3D, any sort of 3D design? 1, 2, very good. Okay, sir, what sort of software are you using? Yeah.
I'm using AutoCAD, SketchUp, and recently I moved to Writing.
Oh, okay. Okay. Did you pay for it? No.
Afterwards, I'm Writing.
Oh, okay. Yeah. I think students should never pay for lessons. But what about the young lady in the front? Sorry? Oh, AutoCAD, really? Okay, so you're in more like building industry or bridges, that kind of thing. Okay, very good. I got 2 answers. Okay, so this is today's class. Okay, it's gonna be your final exam by your professor. Okay, you better take a picture. Now, okay, so this is how we make iPhone or anything, right? This is what your dad do, right? They don't sleep. They don't take you to Disney Park. Well, you don't want to anyway. You're too old. But this is what your parents, if they are into technology, they are producing things. These massive confusion diagrams, processes are something that will confuse you, and they don't really teach you in school. Okay? So in the beginning, you have sales stage, engineering, operation, and aftermarket. Okay? So usually for the iPhone, you obtain the aftermarket iPhones. If it's broken, too bad. You buy another one? No. You return it, we fix it. Right? How? We gotta track down each iPhone. It's produced in different region, different country, or different factories. We gotta track down what happened to the camera module. Which one did you use? What happened to you could happen to other iPhones. Those kind of things are this inside here somewhere. Very confusing, right? And I don't want to put you guys to sleep, so I'm not going to teach you anything about this. Okay, I'm going to do an easier one on you guys. Who here understand now, have any idea about what is digital twin right now? Digital twin with the product, with the world, with any sort of design? Anybody want to try? Okay, what is virtual twin? You probably have like play around with it. Anybody want to guess? Okay.
Who has heard of?
Try anything. Anybody have heard of it? No? Virtual twin? Digital twin? They don't teach it on Netflix? Disney Plus? They don't? Want to take a guess? Anybody want to take a guess? Sorry? What's the middle guy? What did you say? A copy of what?
Copy of
A copy of myself. Okay? Yeah.
like
that
a
makes
digital
sense.
copy.
And what about you? 3D model of human. Okay, very good. All right. So yeah, so maybe those kind of answers are pretty good. All right. A copy of something. It's digital. It's twins, right? You have twin brothers. So we give out candies for the people who sleep. You gonna catch? No, I don't want to handle your computers. All right, Mentos. Oh, did I hear? I didn't. Man, I didn't answer. I didn't know. That's why I tell you to go in the front. I have to go back and give you candies? Oh my God. Universities, huh? We teach you to be lazy with the little automatic machine that goes up, right? That's why we should design. All right, digital twins. Now you're gonna answer, too late. Digital twins. Okay, so digital twins. Nowadays, we are trying to do something with digital twins. What it does is we try to make copies of the real world. Okay? That's all we want. It's very simple. Okay? And why we call it digital twin? Because we want to confuse young kids. So we can make money, make salary. Right? Now, I'm going to show you a video just so that you don't fall asleep. Take a look.
Virtual twin experiences are scientifically accurate computer models of anything. Virtual twin experiences can test any idea before you try it in real life. Virtual twin experiences also help you make sustainable choices at every step. Virtual twins help researchers develop new molecules and materials, eliminating most physical testing. With virtual twin experiences, you no longer have to break prototypes to know they're strong, or work as they should. New manufacturing plants designed with virtual twin experiences operate at top efficiency. As parts arrive and finished goods ship, virtual twins optimize transportation. They build serviceability into product design, so repairs are easy and products last long. Virtual twin shows all materials used in a product, so recyclers know what to recover and how. Virtual twin experiences optimize sustainability at every stage.
Okay, so a very important thing is that virtual twins are scientifically accurate, right? Computer model of anything. What does that mean? So when you see, we were asking what sort of like a 3D design software or any 2D design software that you use. It's actually a design, an accurate one-to-one measurement of the size that we can understand and being used to be produced later. Okay, this is not your typical video game where size and proportion doesn't matter. Okay, so when you design a car, for example, everything has to be proportional. Okay, it has to have meaning. Okay, so these are the things that to follow the Rhino, the SketchUp, or different kind of rivet you have to do. It's either on building. This is how we design your cell phone to begin with, conceptual model and detail model. We have to design everything down to the wires, the speakers, or even the wheels and the door and the electrical or mechanical systems, what have you. Okay? So, all right. So the picture is worth more than 1,000. Sorry, a picture is worth 1,000 words. Okay, so you hear that phrase a lot. Okay, I got a question for you. Anybody recognize that car on the left? So?
Russian one?
Oh man, you get too much candy. It's PUBG. All right, I'm gonna give you a small one. All right, catch. Whoops, sorry. Hit the roof. All right. So it has nothing to do, but on the left side, right, it's a computer game or a cell phone game. Okay, it's a car, right? On the right side, it's what my company do. We sell tools to design cars, right? So inside the video, what's the difference between them? As you can see on the right side, when you design, you can see the inner side of each nuts and bolts, and you know the internal frame, the wire, the electrical system, everything has to be designed. Okay? On the left, it's just a video game. The size doesn't matter. The prettiness matters. It has to be lightweight. So typically for this kind of file, if you understand, this kind of file can take up to 500 gigabytes of space, right? Ranging from 100 to 500, depends on how much data you put in the game. And typical for this sort of a car model, it's not even more than 10 megabytes, right? It basically just shell. It has no internal electrical system. It has nothing. Basically, it has to be lightweight to be able to run on your PlayStation 5. Okay, you don't want it to be heavy. So that's why when you do see all the designs on the television, that's why it's always ugly. We don't care about prettiness. We care about accuracy. Okay, so this is what you have to watch out in the future, right? Anything you design could collapse, could have faulty design errors. Okay, so that's what we are trying to do every day. We fix errors, we design, we try to design again. Okay, so that would be the difference. Okay, but this is all designed in 3D. Okay, but is it really photo of like a 3D? Is a picture more than 1,000 words, or it has no words at all? When you see the pictures, it means different things to different people. Am I right? Some of you saw video games. Some of you thought, okay, that's a nice car, but I don't know what that means. It's blue. Now, for designing any sort of design, it has to have meaning. Okay? For the car wheel, we gotta specify what sort of metal you are using. What sort of rubber? Is it Goodyear? Is it Michelin? What size is it? Okay? And not to mention the requirements. It has to be able to run during the winter time. Right? It has to brake within certain distance. This is the design specification. Right? That is very different. So that's why we need a CAD tool to design with meaning, with words, actually written down. Right? This is glass. What sort of glass is used? Right? Tempered glass. What sort of hinge? What sort of design material is being used? Okay? Those kind of meaning, those kind of words or meaning to the picture, actually, or to the model, actually help later on when it's manufactured. Okay, so I know which sort of wheel to use, what sort of ring, what material to produce, and who do I buy it from. Okay, so these are kind of things that we should watch out for. Now, when we break it down, there are really sort of three types. There could be more. Okay, three types of category that we are actually designing for engineering. Okay, so you have designers, you have engineers, and who work on systems, right? So if you think mostly recent the car, it has autonomous driving. Okay, it has like an ACC system, the radar, and then actually detecting the speed of the car. Okay, those things need to be designed and to collaborate together. Okay, so that's the thing that is complicated world, and that actually, if you figure it out, that's how you make your salary in the future. Right? It's nothing complicated, right? But I'm going to show you. So what does it mean when you use like a CAD tool to design? Okay.
Your imagination. Dreams transform into shapes, evolving and interacting in all dimensions. Form, materials,
in designing shapes. CATIA is about engineering systems in the context of the whole experience. A flash of inspiration and innovation, creating precise scenery from early concept to stunning visual experiences.
It's about style and usefulness. The user interface is clean and coherent. You get the idea very quickly. I'm very proud to be a part of the CATIA Imagineers community.
Now, thanks to the latest CATIA tools, new exciting perspectives are possible. CATIA 3D experience will gradually enable us to tend towards a virtual experimentation of the aircraft.
CATIA 3D experience helps us to translate our interactive AI to global performance.
I'm just going to skip over there and skip to this next slide. Let me mute this.
And we can then human.
Okay, so we have a tool to design 3D. You may be wondering, why do we need 3D? Just to manufacture things easier, right? Now, as you can see, if we have the 3D models, the user can experience it. Okay, it might be in the previous video. And imagine when you go to shop, buying Nike shoes, they let you see 3D shoes, right? So same thing as car. Before you buy it, you have the capability to choose the inner lining. Is it leather or fabric? What color do you want, right? When you buy a house, you want to design your classroom or design your house, you actually generate 3D models and try to render to be prettier, so that you buy it first. But let you see before you purchase it, okay? Now, this is the same thing, okay? What they are trying to do is, this is the actual size models that we typically every day, we simulate things. We put real human models, well not real human, but real human size models inside a virtual car. That's what we call virtual twin experience. What we are looking for is, when this model turns the head and watch the real end mirrors, right? Is he able to see it? Did I design the seat too high, too low? The hand, the elbow, the gestures. When you drive for 2 hours, right? Your hand, your elbow position and angle, it affects you. Now, you should understand that long time ago, we actually built real clay models or prototype of everything. It's slow, it's costly, right? And the first model, prototype never worked. Okay, nowadays we build everything using computers, right? So you can actually have 3D model and sort of like figure everything out before you produce it. Okay, so that's the things that we are trying to do, right? You have like for the user experience that we want to make pretty so you can see the inside. But for the simulation of behavior, how you break the angle between your leg, your knees, it's going to affect the ability to break early or late, right? And there's even sort of system design where it affects how the wiper goes, how your car lights when you turn, what sort of angle it turns. So these are kind of things that we are doing, and we all need 3D model. Okay? So by the time you get out of university, you say you only know how to draw a 3D model. That is only the basic thing we are doing right now. Right? This is like a working at 7-Eleven thing for the high tech. Okay? There are more things that you can do than just 3D model. So my advice, don't learn how to draw 3D model unless you're very interested in it. But our life spent, because it's actually a profession as well. We spend tons of time trying to draw faster, automatically, right? Those kind of areas are one of the professionals as well that can actually make a living for 20 years. But if you are really interested, not in the model, but if you're interested in sort of area of simulations, Okay, it's a big topic, right? So what typically the automotive or even buses or different kind of area, what they want to do is simulate before they send for their car crash test, right? If you don't have a computer, then you gotta send 10, 20, 30 cars just to test and being able to pass the safety regulation. If you cannot pass, send another one, right? You build another one, you send it, you crash it only once, one-time deal. But in the computer lies the world, okay? When you have 3D design of the digital twin of the car, you can actually crash it, and we can actually put texture on it that look exactly and bend exactly like the real car. Okay? So these are sort of simulation that might interest you, or is it something that we are doing as well in everyday life? For example, when you drop your phones, all right? When you drop your iPhone, we design what angle, right? What speed, what height it drop, and the glass break so I can make more money. No. We try not to do that, okay? So that comes back to the ethics. Do you want to design something that will last forever? Or you want to design something that only lasts for 1 or 2 years? For example, the switchable iPhone batteries. You have to take out the casing, right? Just 10 years ago, we were able to swap batteries, but you cannot. So these are kind of things that you have to watch out for. You want to make money, or you want to protect the environment? We don't know, which interests you. Okay? So 3D is very nice. There's a lot of things, different area that applies to your sort of like area of interest. And let's go into medical. If we have 3D, how can it help the industry? Okay? The medical industry, we actually have, you probably know there's CT scans. It takes sections of your body in 2D. And when you see the doctor, and then, anybody went to CT scan or MRI before? No? Never? Wow, nice. Young, healthy body. Not like, okay, I'm showing my age right here. So what it does is actually it cuts you up. It scans like a 2D X-ray that you see, but you can actually build 3D models. So as the technology progresses, the people will try to understand and study the heart. And this is what we are doing right now. Okay, using the technology of 3D.
It is really an effort to bring together the best science that's out there for modeling the cardiovascular system using computational tools. The biggest challenge that the cardiologists have is understanding the individual patient. The technology we have today often provides fingerprints or an indication of what the problem is, but not a direct analysis of what the problem is. It's very difficult, expensive, and sometimes very invasive to actually see what's going on. What we think we can do is we can take a simulation of that exact heart, taking our understanding of the physics of the heart, and providing that in full 3D to that cardiologist so he can actually get true representation of what's happening. So we used our 3D technology to create immersive 3D environments. And we built 2 scenarios, one which is a virtual operating room, which allows you to see how a surgeon could be looking at a patient on the table, and you can investigate surgical procedures in real time. The second scenario is really a deep dive investigation into the heart itself. And that's where the interesting part comes. When you're in that heart, it's beating, sounds are going, everyone has the same reaction, where it takes them to a place where they say, oh, this is really powerful, I feel how this is going to do this.
We hope that this project sort of takes the top off the box for research. In the digital world, we don't have to worry about the specific patient. We don't have to worry about legal issues. We can...
All right, I'm going to stop here. So is this nice? If the doctor is operating on you, now you're too healthy. Let's say your loved ones, and they're still young. Right? Okay, let's say your puppies have heart problem. Wouldn't you want your doctor to know what the heart look like or the artery before it cuts them open up? This is how we do it right now. We cut them up and see what's wrong with it. right, on the fly. And then you say, oh, there's something I never seen before. You don't want that, right? You don't want your doctor to get spooked. Now, these are something good for educational, right? And it's good for something that we're trying to understand the heart before we go into surgery. Now, if you add AI, right, or machine learning, because you guys have watches that detect your heartbeat, right? If you have Apple Watch, if you fall, right, or it actually have ECG or different sort of sensor that actually tells you your heart has problems. Those kind of big data, if you feed into models, you probably could train the model in the future to predict when you're gonna die. Is there something else? Is there something that you want to know? Yeah. Okay, so maybe we don't want to know that, but that's how the medicine world progressed. They are going into 3D as well, right? Going digital twin heart. Okay, so this is one of the applications more and more in the future that we are also testing out as well. Okay, so for the following program, viewer discretion is advised. Now, I gotta give you a little bit background before I jump into the next video, right? Since we are talking about medicine, right? There's a mom, right? Naturally have a kid, right? And sometimes kids get sick, right? So when people lost their loved one, they tend to want the medical world to progress, either in the cancer world or any sort of sickness. They want the technology to progress, okay? So I'm just gonna show you, okay? You guys can lie down and sleep, pretend that you don't want to see this. But I'm gonna show you, all right? You guys ready?
Yeah.
All right, good. Let's go.
실시간 렌더링 기반의 프로그램을 활용해서 프로젝트 개발을 진행했고요.
그래도 아까 그렇게 해서 딱 나오니까 되게 좋더라고요. 생일이 7살이라서 좀 가슴이 아픈데 지금 10살 됐는데 이제 11살 됐거든요. 네. 시간이 계속 멈춰있으니까.
Okay, so this is 3D. This is digital technology. Is it touching? Very touching, right? Every time I see it. There's a full story, just search on YouTube. There's like a full video of it. Okay? So, all the girls probably are crying? No?
I was about to cry.
Almost, okay. You gotta give tissues to the girls. Right? All the guys are thinking, man, I gotta make a girlfriend. Using 3D technology. This is what I'm interested in. So what sort of data or what sort of technology is being used? Sound, right? This sound that you have to adjust to the sound of the passed away little child. How do you make sound to sound like your daughter, right? So there's like a deep fake voice that's happening in the world. We can talk about more. Visual, right? We have a lot of VR headsets. You know, it going to 2K, 4K, and even 8K, sort of like a VR device, right? So those are the things. It's getting more real, and it can help you to get experience in the virtual twin, right? And there's texture, right? How do you make the skin? Because in the world of texture, you cannot make the skin too perfect. And everybody have freckles, you know, pimples, that kind of things. So you gotta make something to be more realistic. Just when you watch a movie, like Avatar or what they call Ready Player One, that kind of still look like a video, right? The Battle Angel still look like somewhat computer-generated video, but it's getting there, okay? As technology progresses. And modeling, right? You see, you take a photo of the child. Sometimes you have to use point cloud, like a laser. You know, if you have iPhone 12 and 13, anybody who have iPhone 13, 14? One? Pro? Who has iPhone Pro from 12 and above? No? Oh, man, I thought it's rich crowd of students. No? There's one. Oh, man. Okay. Do you know your cell phone have LiDAR camera? Anybody know what is a LiDAR camera? Not you. Give other people a chance. Right? I'm going to run out of candy by the end. Anybody want to give it a try besides him? LiDAR?
LiDAR is a abbreviation of light detection and ranging. So LiDAR is an abbreviation of light detection and ranging. So it uses light inputs to detect objects.
Okay. Good. Fair enough. Very good. All right. So I'm just going to give you, let's see what I have. Bar. Anybody skip lunch? This is time to get it. If you don't answer the question, you're not going to get it. All right? So, yeah. So you have LiDAR, right? You don't even know it's on iPhone 12 Pro. You basically can use your cell phone to scan and make 3D model of it. What it does is it offers light sources to detect any surface, right? And make a 3D object out of it. Okay? So it's sort of modeling, point cloud is the same technology. Motion sensors, right? We're gonna sense mom saw his hand, her hand, and her head turning, you know, which way it goes. It has a lot of different technology all together, and most of all, it has to interact. When you play video games, the computer sort of interact. You know, when you kick it, it doesn't do anything. It depends on the programmer, how they program this NPC, right? You guys have seen the movie, NPC? Okay, anyway. So, interactivity is basically what is actually the goal of the video that you just saw. So this is something that is very nice besides the 3D model of the producing product. Okay, so that was happening in the, how do you say, in the Korea. Okay, so it's a business that actually doing things to help someone who have lost their loved ones. But do you know, in Taiwan, all this sort of like a technology, we have this almost 20 or 40 years ago. Before you were born, we have this sort of things to test our virtual twins, even before computer exists. Okay? Have you seen this? Okay, probably the foreigners who doesn't know, okay? Now we have virtual reality of hell. That's what it is. It takes you to see your loved ones. I don't know how. Anybody tried this before, by the way? No? No, I'm not encouraging you guys to, but okay. So it's just a joke. Okay. But let's go back to the topic. All right? Let's step aside from the engineering. Is it ethical? Right? Is it ethical to bring back, I have all the technology. Is it ethical to bring back the dead ones? Like the video say, some people say, you cold hard a company, you're making money out of dead people. Right? Is it ethical? Is it something that you want to do? Right? We want to make iPhones that only last for 4 years. Well, no, actually, iPhone lasts more. We want to make Samsung. Anybody from Korea? I don't want to attack you guys, but think about it. When you see this movie, do you guys know what movie this is? Which one? 5? The girl on the left with fingers up. Alright, there you go. Oops. Alright, is it 7? I don't even remember. I just took the slide, but everybody says 7, so it's 7. Now, is it ethical? He died while the movie production, right? How did you go to the end? Is it ethical to make something like this? Of course it is. We want to watch the end, right? Yeah, but on the 8th, it's not there anymore, right? It's getting more ethical. But I'll let you see this. Hope they don't come over. Okay, so sorry, I think I turned the wrong way. So this is one of the famous singers before you were born in Taiwan. Is it in Taiwan? I think so. So she's dead, right? People using any sort of 3D projection or different kind of technology to bring her back to life on a television show, right? So have you seen it? For in China, they're doing this as well, right? So stop this. Anybody heard this tune before? Yeah, I'm surprised. Oh no, I'm not surprised. You gotta be really, really old to hear this tune. Or you say, oh, my dad was playing this all the time, I hate it. Now, I think Zhou Jielun, the singer in Taiwan, did a concert before with her, Deng Liqu, right, the singer, on the stage, right? They make money, is it ethical? Right? We don't know. You're not making money, of course it's not. If I'm making money, yeah, it's ethical, I want to make money, right? So it's hard to say, but people are doing it in China. You have concerts that bring back, let's say that can we bring back Michael Jackson? Is that a good idea? Do we really want to? No. Well, you are the future of our generation. You guys have to decide that. I'm old, I'm ready to die, I don't care. Right? Anything you design in the future, actually decide what is ethical or not. No, actually your boss decides. you don't get to make decisions, right? You just help design the system, the technology, and it's up to the public to judge, right? So you're probably going to see that more and more in the future, right? So how will technology evolve, right? You have virtual reality, right? And you have like rendering getting better and better, harder to distinguish is it real or fake, right? Basically on the television commercials, a lot of it, or even movies, it's hard for you to understand is it CGI or is it real, right? And even if about deepfake. Now, another question. Anybody understand what is deepfake? Is it called deepfake? Right? What is it? All right, I'll give you a try. What is deepfake?
Put somebody's face on the video.
On the video.
Yeah.
Okay.
Like
Yeah.
Porn or something.
What was it? What was it? I didn't learn that word. Yeah, I think there's like a famous, one of the YouTubers actually did this.
In Taiwan,
Yeah. That's sorry. So what you do is, deepfake is actually taking a lot of images, and then you put inside the computer different angle of the faces, right? And you mask onto another video, right? Basically, this camera here is recording my face. You could put other people's, or even a girl or kid, right? And put on my face, and you're gonna see a famous person talking, like Donald Trump. So you've probably seen this. People actually doing deepfake, putting messages out. It's a fake video, and actually talk like him and look like him, right? So is it something ethical to do that? Of course it's not, right? There's law, regulation, and I think there's like a YouTuber got punished for doing something like that, right? Thank you for sharing, watching a lot of that kind of video. Okay? Now, this kind of deepfake is something in the future that you're going to see more and more. And you really have to understand a lot of things, technology are meant to be used for good, right? So if you don't understand deepfake, let's see this.
That's most definitely not Tom Cruise. Nor is this with me in our LA bureau. This is serious breaking news, but a little behind the scenes, a little flavor on it with one of the most legitimate correspondents on earth. Now, before interviewing me, Jacob, you fixed it. Hold on a second. Be quiet. Safe.
You are deepfake Tom Cruise. That's me. That's me.
Miles Fisher may have an uncanny resemblance to the superstar, but using advanced technology, what he's created is far more than an extraordinary impersonation.
Have you guys created the best deepfake that's ever been made?
I think we've created the first deepfake that's so realistic that a large majority of people have seen.
Not only seen, but fooled by, including at least one of the world's biggest celebrities.
This is the one that Justin Bieber thought was real?
Fisher says looking and sounding like the leading man made it difficult to chart his own path as an actor. So a year ago, he decided to lean into it, stumbling into a role with repercussions far beyond Hollywood.
As I find myself the unofficial face of this deepfake movement, it's important to learn. And I'm fascinated by this. This is the bleeding edge of technology.
It started when Fisher contacted Belgian visual effects wizard Chris Boomham. He began creating viral videos for fun, and they're only getting better.
About 5 days, maximum 6 days, I could turn around something like this.
So you've gone from weeks to days in a matter of a year. This technology is advancing that rapidly.
Yeah.
For his part, the real Tom Cruise hasn't asked the duo to stop, and they haven't monetized the TikTok account. Cruise didn't respond to a request for comment from NBC News, but their work so successful, Fisher and Ume's company, Metaphysic, is now in business together, looking to convince others it's worth paying for this technology.
How can we use this technology by creating kind of identity rights? Let's say Tom Cruise gave us the consent for this likeness, where we can move beyond just small heritage plays. Everybody gets paid for that intellectual property.
That does raise ethical questions about where you fit in all this.
The thesis of this company that Chris started begins with ethics.
They say they'll only take on projects they consider ethical. But some worry leading companies and individuals to make that decision could be a dangerous precedent. Congress has held hearings on deepfakes and AI, and the FBI tells NBC News they're following the rapidly developing technology closely, saying we'll continue to investigate any violations of federal law
Right? So that's the thing. Hopefully you understand this. Okay, there's a lot of technology going back in the background, but did you hear? So you know it takes a couple of weeks to generate. Now it only takes 5 days or 6 days. Right? In the future, you can go real time. I think they can go for real time right now. And there's even crazier thing called deepfake of audio. Right? Basically, that I can sound like Morgan Freeman or Donald Trump when I speak and through computer generated. Right? Now, to put the good use, that there's nothing scary about it. But have you ever picked up a phone before? And all you heard in the background is like a little kids crying loud. Say, "Mommy, they're hitting me, they're killing me." And the bad guy said, "I have your kids." And the deepfake voice sounds exactly like your kid. How scary would that be? That would be scary, right? And you guys are putting your faces on the Instagram, your voices, your vlog, that people record, they have access to your voices. How easy is it to download your video? I got 10,000 of it. Using audio deepfake, make a phone call. And your mom wouldn't know any differences. Right? So that's what I'm saying. You are the future of the generation of the future. I'm not, right? But I'm scared to get this kind of call, right? So, what now? This is scary, right? I don't mean to make you guys, because part of the name of the course is called Engineering and Ethics. That's why I'm going into that topic, right? So hopefully you guys put the new technology into good use. Okay, I'm gonna ask a hard question. Anybody know this? This girl? Raise your hand. Oh man, only one? Big chocolate bar. Oh, not chocolate bar. Healthy bar. What's her name? You don't know? Too bad. Quickly Google. Use your new technology, image recognition, to find out who it is. You don't know? All right, I'm gonna keep this part until somebody shout out the name. All right? It's on YouTube. Okay? Now, what this YouTuber does is she has all sorts of sensors, right? She creates 3D models of this girl, right? And she put it on the live stream, right? Live streaming and talk to people with that, right? And behind, nobody ever have to see her. She called herself as technician, right? But this girl, anybody found the name yet? No? Okay. Right, so you're gonna see more and more, right? Between real-time 3D model and the reality of the person who's acting behind. Okay, so they're doing this a lot on the movie, but it's getting more and more real-time. So of course, it looks like a video game right now, but as computer or new technology progress, it's gonna get better. How better? Now, on the right side, this is, I think it's China, they actually make news anchors using 3D models. Okay? So they can put out scripts or even live speakers, right, who speaks, and then to produce like a news, right? So by doing this, right, the original person, where is she? She probably lost the job, right? So a lot of people ask, young kids might ask, what should I do in the future? I have no idea. I'm not in the future. But I would say, if you ask me, I would say, if you are in a job that make other people lose job, then that's a good job. Right? You guys are making robotic arms to do what? Make fried rices. Oh my God. Right? And who's the cook? Where's the cook? You always see those machines, you put in coins and there's a ramen noodles comes out. right? We used to be people who cook for us to eat. Now, we don't even wash dishes. So where are those people going to? Right? And they are making, what's it called? Amazon store? No clerk. You can just walk in, pick the things you want, and then you go to the gate, there's a sensor here, and then you throw the stuff out, they catch it. You don't pay for it? Oh my God, what kind of store is that? But think about it. In the future, people are going to lose jobs, right? So do you want to be the one who's making technology and helping people lose jobs? Or you're going to be the store clerk when the robot comes in and you lose job? You decide, right? The people who's making new technology, they're not going to have ethics. I don't know. Everybody got to feed their kids. Everybody got to make money, right? But how you progress in the future, it's something that it's very interesting to see in the future. Okay, anybody see has found the name yet? What is it? Call Michael. Very close. You're missing. Michael sounds like a guy. Anybody else? Michael? Okay, I'll give it to you. I call him Miko. Michael sounds like Michael Jordan. I don't know. All right. No, that's all right. Yeah. Right. So yeah, just to keep you guys awake. Right. That's my job today here. So this is something that you're gonna see virtual anchor host, right? Virtual movies, virtual sort of anything. Okay. Now, you see a lot of sort of like 3D model, interaction, simulation, that kind of thing. We're still missing one thing. Okay? It's called IoT, Internet of Things. It's sort of fourth dimension. It has nothing to do with 3D, but related. Okay? So what is IoT and big data? Okay? IoT or Internet of Things are the sensors in your home. It's like, hey Siri, turn on the light. There's sort of a micro sensor, right, inside your phone, listens to that. And you might have a thermostat, like this kind of system, that detects the temperature of the room. If it's too high, it sends out signal to cool down the room. So there's tons of billions of sensors in the world right now. Okay, what does it do? Right? It actually helps us to understand the world. So, this is a lot of stuff. Like getting you into sleep. But we have a lot of devices, right? Basically, you only have to understand between real and virtual is you just open your Google Map. The Google Map, when you do the navigation, it actually tell you which road is congested, right? It show you orange or red, right? Those are sensors on the road or even your cell phone that actually feed back into the system, right? Then you have connected city that tell you which part of the city is congested, right? Your smart lamp or a lamp post on the street will turn off the light automatically. So these kind of things are a lot of different sensors, and it can connect it to the machines, the plant, or even the car. Okay, so we're collecting billions of data each day, trillions. Okay, we're collecting everything a lot, right? So as you can see, if we apply, we can understand the rotation of it, the temperature, the vibration, everything inside the machine factory. Why do we want to do that? Because we want to predict when will the robot fail. When is it that it needs maintenance? When it starts vibrating heavily, you know it's going to break, right? When your kids cry too loud, you know it's going to break. Okay? So these are the real and versus virtual. And for the virtual, it doesn't really tell you where it turns. That's why we need sensors to sync up. Those are the IoT things. And we keep a track all the records inside of it. And we have virtual twin models, right? And sometimes you want to refurnish the plant. You want to try different things, right? I want to fire 20 people, so I'll replace it with robotic arm. I want more compact manufacturing lines. That's what we're doing. We want things faster, to build faster, people to work harder, just so that next year you can get your iPhone. All right? So who's pushing who? Okay. So you can see, we can plan and simulate robots, but we couldn't do this 20 years ago. Right? You use a piece of paper, you use a ruler, but right now we can do it all digitally, and this is all synced back to the 3D model that you draw. That's why it's important to be proportional. It has to be accurate. We want to know if every robot knock into each other. We want to know what sort of degree they turn and everything like that. Okay? So this is more like a micro level, right? Let's go macro level. Smart cities. Let me see if I can get this right.
Let's just jump to the result. Virtual Singapore, running on our Singapore cloud, is really about big data. We manage today in time space a huge amount of heterogeneous data, 170,000 buildings with their semantic usages, 4,000 kilometers of roads, 3 million trees. Remember, Singapore is the city in a garden, and many other data like shops, businesses, point of interests, urban furniture and demographics, and ultimately to connect with the 6 million citizens of Singapore.
So Singapore made the entire 3D model of the entire country. Okay? And inside their sort of virtual city, it's connected. Government knows everything. Right? We know each tree, where is it planted. We have geolocations of the tree,
Let's now look at the usages of 3D experiencing
everything.
And how it connects with industries. First, see how we can leverage the city referential for civil engineering to do better planning and sustainable investments.
So this is good when you want to design a bridge. You're doing the 3D model, but you don't know how to put in the real
fully designed in the 3D experience platform to in context of the city referential. We can very quickly see the impacts on pedestrian bridges, avoid collision with sewers, pipes, electrical cables, take into account geological information.
This is why you are in traffic all the time. To tell you the truth, we don't know what's underneath. It's built 20 years ago, 40 years ago. We only have 2D lines. We don't know how deep. Right? We just think, open it, oh my God.
Another interesting use case is public transportation.
That's why you're out of water.
For new residential area development, it is important to check reachability to services. For instance, make sure that any of the new habitations building are less than 10 minutes from schools or medical centers, the green areas, that in 15 minutes on a bicycle, you can reach services of interest, the blue areas. You can then plan for bicycle reserved paths and check over time and communicate on the safety index for such trips.
So this is more like Google Map 2.0 or 3.0. You can interact with it, you can put model in it, you can understand the entire city, and you have the building model, it's accurate, right? And you can do the simulation. What sort of simulation? You can do wind simulation on the district, right? To see if the building affects the environment, right? Can we design the charging station to be within 2 kilometers in each district? Right? We want to understand how far the student is walking. These kind of things, if you have 3D Minecraft, anybody play Minecraft? It's the same thing, just ugly. This is prettier, right? You build exactly replicas, and you put IoT sensor inside, right? So when typhoon comes, the water rises, right? You know exactly where and what is clogging the system, right? The underground pipe is draining well, everything. These are kind of things that city government are trying to help Taipei City, any city in the world. Some do it better, some do it worse, right? But it would be nice if you have a digital twin that you can play around with. Now, back to the data we are connecting, right? We have city. What about the data? Right? I'm going to skip this. Just don't put you into sleep. We have real world evidence, right? You got to compare between real and industrial. Industrial, you want to see what's going in the product, in the factory, and the knowledge capital. Okay, so all those data you have to be connected and put into good use, right? So these kind of things are just something that can help the city to help you design car, airplane, or even the science model, simulation, right? You probably know this by now. Now, with simulation itself, it doesn't mean anything. You have to add like big data, intelligence, right? There's AI. We want to calculate, right? What sort of video you're watching. We want to know who you're going to vote for. Before the voting, we put out messages to influence your vote, right? Can we do that with Twitter, with Facebook, or Instagram? Yeah, we can, right? So that's artificial intelligence for you in a minute. This is something scary, right? But for us, if we are producing products or the environment building that we want to collaborate together, there's huge amount of different professionals to make something. It's very labor intensive, different technologies, and basically that's what your parents are doing if they are into high-tech areas. Okay, so IoT, back in 2016, there's sort of like in Singapore, they make a device very much like cell phone. It detects the air pressure sensor, it has light sensor, infrared sensor, microphone, temperature, what have you. Okay, it detects humidity and everything. It records 50,000 students. So every student wear one on their neck, all right? Like this is like a big privacy breach, right? Nobody wants to get recorded. And they record how students travel, right? And the moon survey, you can press on this machine, say I'm happy, and this teacher sucks, I'm sad, And there's like 43 million of staircase climb. Okay, you want to see which school climb more stairs, right? We want them to be carbon neutral. So they are doing this to do what? Well, they're doing this to understand their city, how the students move around the city, right? It's a big data course. They're teaching their students as well, right? You guys are joining 3D model. The high school student or junior high school, they are learning big data. So who's winning? Right? So this is the difference of the country policies. They use real data and feed back to the computer, and the student access the real data and holds competition to the people use big data for what? Data analysis. Right? They want to know the noise versus temperature, right? Versus the activeness. Is these kids run a lot? Right? What happened to this boy? How's it doing in academia? Is it getting good score or bad scores? Right? And then the students have evidence. My house is noisy and I don't have air conditioning. That's why I'm failing. You cannot blame me. You cannot blame I don't study. That's the big data result. Okay, no, using a good way. So there's a lot of things you can use on, right? So there's like a simulation, and you can see how people move. You can see how students go home. So the government can plan buses. Typically, what they find out is students don't go home after school, right? They go to malls, wait for their parents to pick them up home. But to go to school, the parents will drive them. So they have different style of transportation methods, and it's more like a human behavior thing that you have to study on. So that's data science for me. So it's very interesting that we have a virtual city, and then to make it alive. Okay, meaning you have IoT, you understand what's happening in the environment, And one of the stories very intrigues me is what they do it. I think it was like a Boston or New York. Inside a taxi, they have sensors. They plant sensors inside taxis. So the taxi travel around the Boston streets, right? And the sensor detect vibrations. So when the car run over a pothole, right, everywhere. If this pothole here has 5 taxis travel over it and detect the same frequency of vibrations, they know there's a hole there. They will send people come here to fix it. You don't have to call them. There's taxis everywhere, right? Imagine we do that with your iPhone, right? It has a lot of sensors. We understand you're watching Netflix, 2 o'clock in the morning, you didn't sleep, and you still come to my class, and didn't fall into sleep. Thank you for that. Okay, so that's the things that you can use. You have a lot of trillions of data, but not a lot of people know how to use them. That's the world right now. We collect them just because everybody's doing it. So if you are interested in data science, that's something we are missing right now. People pay big bucks. They pay a lot of money for it. Okay? So same thing as simulation, like what I said. The wind speed affect the temperature, the noise evolution, and how is it related to real estate prices, how much the house is selling. When it's too noisy, it happens in Singaporean, they don't like to live near the streets. So the price naturally drop down. Okay, so that's that kind of simulation world versus IoT, big data, 3D model, a lot of things all together. That's something that you can try to understand in your future. Okay, hang in there, I'm almost finished. All right, you have places to go to? All right, give me 5 more minutes. All right, so smart city. Okay, so it's data driven. So Singapore is doing something. This is called Smart Nation. If you're interested, go on internet. Right? You guys can do better than old people. Right? Imagine I have to teach my parents how to use a mouse, and my kids teach me how to use Instagram. Oh my God! So that's something interesting. But in the future, it's data driven. What I'm telling you is, the generation right now is very difficult in analyzing all the data, right? So, this is what I'm promising you. Pop quiz. Get your pen and papers out. Let's have no, I'm kidding. Come on. Who actually reached your work? It's a simple question. Let's see if you are paying attention. And this is my last gift to you. Hopefully, you guys like it. How do you call it? Ferrero Rocher? Okay. Let's do it by raising your hand who's the fastest, and I'll call them. When you see the question, please raise your hand, except 2 in the front. You guys probably know the answer already. You guys ready? Yeah. Okay. Are you guys ready? Come on, the class is almost finished. You're supposed to be happy, right? That's not what happened in my work environment. After I work, I feel tired. Okay, 3, 2, 1. Raise your hand. What? Oh, okay. All right, there we go. Everybody clap. That was a hard question, wasn't it? There you go. Happy Valentine's Day. Okay, so 1 pass. And the rest of them fail. Okay, so 3 more minutes. Right? I got 3 more minutes to give you some advice. I don't want to, because I don't know the answer. But the secret to success. I don't know if I'm successful or not, but I'm gonna give you a little secret. Alright? At least I'm not in the street begging for food. Right? I still got work. That's a good laugh. I gotta give her a candy. Let's see. I'm sorry, sorry, I don't have more anymore. Okay, too bad. That was like my last one. Okay, now listen carefully. I want you to remember, besides all the technology things, this is the most important thing, that you're probably not going to hear from other people, and you never heard of. Okay? Because in the future, in 3 years, you're going to step into the world. Some of you go to grad school, and you're going to face with this question. You're going to find a job. So what the secret to success? That's the reality. That's the secret to success. Okay, so if you are not as good looking like me, average dude, walk on the street, nobody ever talk to me, okay, then you are indeed. Okay, so what can you do? Right? I'm going to share with you, right? It's not really, you take it or leave it. Okay, this is what my professor, 20 years ago, my professor told me. Okay, what he told me is dress up nice. What does that mean? When you get to work, dress up nicer than the people sitting next to you. What does that mean? If he wears jeans, you wear pants. Right? He has running Nike shoes, you have leather shoes. Right? If he has t-shirt, you have shirts like me. If he wears shirts, you use the iron, you press that damn shirt. Make it flat. If he wears shirt, you wear a tie. Right? If he wear a tie, you wear a suit. Right? What if the goddamn guy is handsome, is wearing a suit? You marry a rich woman. That's why I press my shirt. Right? I act like I have answers. That's my skill. Right? I come here, I have no idea what I'm talking about, but I act like it. You look nice because I'm ugly? I don't have good looking abilities. So that's the reality. Always look nice and look professional. That's going to help you down the road. Right? Or you can dress up sloppy. I'm not going to give you a job when you interview. Right? But do it regularly, every day when you go to work. It actually pays off. But, okay, that's not the only thing. Okay, there's another ingredient that actually can help you. Okay, the one I talk about is something that personally works for me. Dress up nice, people treat me nice. I get higher and higher by luck. Of course, you have to work hard, but there's an ingredient to it, and I'm going to share it with you guys. Okay, so the secret ingredients to success. It's coffee. Right? You can last until 2 a.m. watching Netflix without coffee. I cannot. This is what age does to you. Right? What does that mean? It means work hard. Right? There's no holidays. Right? There's like after hours. Just look at your parents. They work hard for it. They don't talk to you. They go to office during weekends. At night they have meetings. And they have computer doing virtual meeting, right? And your professor sitting here have to listen to me. That's painful, right? So work hard, right? There's nothing you see today require you to learn calculus. That's the reality. There's no use to it. I'm very good at calculus, but it didn't really help me in making iPhone. So what it means is when you get to work, drink a lot of coffee, start working. Just like when you write your term papers and you learn things new and don't worry if you don't perform well, right? Or you can listen to me, like try to find a job that fire people. It's a good job. Okay, so that was my presentation for you all about this entire nonsense. Hope you enjoy it. And any questions? Any questions? No? Okay.
Before you ask questions, it's time to thank our Thank you. I would like to comment on the several secret ingredients in the last couple of slides. Mr. Joe Chen mentioned about being nice looking. I just saw something similar in my lab just today. A couple of days ago, there are several undergraduate students who came to my lab, and they are looking for opportunities to join my lab to become master students. So I asked my students to kind of like an interview, a more casual interview to those undergraduate students. And today I asked them, hey, which one do you think is better? So when I asked about one person, a female student, one of my female students said, oh, this guy's great. So I think he's good looking, probably help a little bit. How can a female student think this male student is great just after chatting with him for 10 minutes? So definitely the other guy looks okay. The one who looks nice got a good comments from female students. So I'm not sure if that's true, but definitely dressing nice, being clean, being professional, definitely is important. Another thing about the ending is coffee. I remember there are times I ask my students, hey, do you drink coffee? Do you want to get some coffee? There's always students who say, oh, I don't drink coffee. Then I know, okay, I can give him more words because he's not tiring enough. Anyway, so very interesting talks today. Does anyone has any questions or asking for more chocolates? Okay, so thank you guys for being here today. Let's thank Mr. Joe Chen again. Remember to write your report, and that's the end of the class.